Determine whether the integral is convergent or divergent. Evaluate if convergent. This is an improper integral. We know by the limits of integration are infinity and negative infinity. So this breaks up into two improper integrals, negative infinity to, say, 0, x squared over 9 plus x to the 6th dx, plus the integral from 0 to infinity, x squared over 9 plus x to the 6th dx. Now, in reality, we can choose this 0 to be any number that we want that's convenient, but it turns out that 0 works fine here, I believe. So, what we now need to do is find an antiderivative of x squared divided by 9 plus x to the 6th. So let's go over here and do that. And what we do is we rewrite this as x squared divided by 3 squared plus x cubed squared. X to the 6th is the same as x cubed squared, and then we can do a substitution. So let u be equal to x cubed. Then du is 3x squared dx. So we need to put a 3 on the inside, a 1/3 on the outside, and our integral becomes 1/3 the integral 1 over 3 squared plus u squared du. So 1/3, the integral of 1 over 3 squared plus u squared is 1/3 arctangent u over 3, and then of course plus c. U is equal to x cubed, so we have 1/3. Well, the 1/3 times the 1/3, let's just go ahead and write it. It's 1/9. Arctangent x cubed over 3 plus c. Well, let's use that in our two improper integrals. Remember that an improper integral with a negative infinity here in a limit of integration becomes the limit as a goes to negative infinity, the integral from a to 0, x squared over 9 plus x to the 6th dx, plus this second integral becomes the limit as b goes to infinity of the integral from 0 to b, x squared divided by 9 plus x to the 6th. And we just found out that those integrals are equal to 1/9 the arctangent x cubed over 3. But now we're going to evaluate the first one from a to 0. And I'll have to come down here a little bit, plus the limit as b goes to infinity of 1/9 the arctangent x cubed over 3 from 0 to b. We evaluate by putting in the upper limit of integration first, so 1/9 arctangent 0 cubed over 3, and then we subtract and put in the lower limit of integration, 1/9 arctangent a cubed over 3, plus similar thing over here, 1/9 arctangent b cubed over 3 minus 1/9 arctangent 0 cubed over 3. Now we know actually that the arctangent 0 cubed is 0 divided by 3 is 0, and the arctangent of 0 is pi over 2. So this first term becomes 1/9 times pi over 2, which is pi over 18. Minus, okay, now we need to figure out what is the arctangent of a cubed over 3 as a goes to negative infinity. To figure that, we need to, one way that we could do that is remember that the graph of arctangent has horizontal asymptotes pi over 2 and negative pi over 2. And the graph looks like that. So, as the input of the arctangent gets larger, the arctangent itself, which is the y-coordinate, gets closer to pi over 2. As the input of the arctangent gets smaller in the negative direction, the value of arctangent itself gets closer to negative pi over 2. So, for this first limit, we end up with 1/9 negative pi over 2. And I apologize, the arctangent of 0 is not pi over 2. The arctangent of 0 is 0. So let's change that. So this should be 0, and then 0 times 1/9 is 0. Apologize there. Fix that. Okay, plus, now we're taking the limit of this guy. Well, again, now b is getting closer to positive infinity. So b cubed over 3 is getting closer to positive infinity. And that's where the arctangent gets closer to pi over 2, remember. So this first term becomes pi over 2. Minus, well, again, we already know that the arctangent of 0 is 0. So minus 0 there. Notice here we have negative times negative is positive. So positive pi over 18 plus another pi over 18, which is pi over 9. This tells us that the integral negative infinity to positive infinity, x squared over 9 plus x to the 6th converges and is equal to pi over 9.